So that's our house. And it was largely a do-it-yourself build, not entirely. But we were kind of motivated. I grew up in Europe. I remember the oil embargo of 1973 really well, carless Sundays and, rationed gasoline, and this set in my mind a strong sense of we got to stop burning so much of this oil. And so I always dreamt of having a really efficient house. And we lived in a couple of old houses, and we kind of tried to fix them up one room at a time, as us amateurs do, knock out the walls, insulate, put a vapor barrier, put it all back together, and it's a little better than it was. But you really can't fix a house that way, is what we found. So we decided, let's start from the ground up and do it over. And so it wasn't all do-it-yourself. So for design, we had help from local impact design, Rob Blakeney in Guelph. He's a great enthusiast for efficient house design, and he was a very big help to us in designing the house. And the foundation and framing work were organized by Just Work and Construction, also locally here, who did an amazing job. So this project started in the spring of 2020 when everything went to pot. We thought it wasn't going to happen at all, but somehow they managed to make it go. So this presentation is very different from the last one. This is all very down-to-earth stuff, and well, we're starting in the earth here. So foundation work, this wasn't us, done for us. ICFs, Heidi really wanted to put the Lego together herself, but they wouldn't let us. So they did it for us. We took the opportunity inside the ICFs to put in 4 of these cubic meter totes. That's our rainwater storage. So, previous speaker, we got a little bit of this rainwater stuff going. It almost lasts us 100 days of toilet flushing, actually, so we're almost there. The ICFs are a little extra insulation. They're about R30 altogether, with more of the insulation on the outside, so we get more thermal mass on the inside. In case you're wondering, this is a crazy tall crawl space you're looking at. It wasn't meant to be this deep, but the soil turned out to be very mucky, and they had to keep digging, and now we have a 5'6" crawl space. It's ridiculous. When the pros were done, this is what we had. So they did the framing for us, unbelievably fast and almost all correct. They put up this thing. And after that, it was our project. And so the first thing to do was to put a roof on it. We learned early on that, now again, this was 2020, people were stuck at home and bored. We were the major entertainment for the neighborhood for a long time. And a lot of people, friends and family, offered to come and help, and we learned to say yes to that because we needed the help. I think quite a few people were worried about me clambering up on this 2-story, somewhat steep roof. I had no fewer than 4 professional roofers among our friends who all came in and helped at various times. You see one of our roofing crews there after the first day we got the front half on. While I was kind of engaged with the roof, Heidi was busy working on taping the seams. And originally I had naively imagined we'd just use tuck tape for this. It turns out that stuff doesn't stick to OSB worth beans. So we did a little research, and I'm sorry, this is not Sega tape, this is 3M tape we used. Seems to have worked out really well, actually. You'll see by our blower door test later. So the OSB around the outside is our air barrier. There's nothing else in the wall structure that is taped or tight or anything. So the idea is the whole thing is sort of vapor permeable, and the OSB, as I say, is our air barrier. Insulation arrived, a big stack of the stuff. Also came locally, actually. Kitchener, name of the company escapes me at the moment, but they make this EPS insulation right here, or at least they trucked it from here. So this is graphite-infused EPS. I'm told this is low greenhouse equivalent, unlike the evil XPS stuff. And the graphite infusion somehow raises it from R4 to R5 range. So we used 3-inch layers of this, 2 3-inch layers together, and Let's see what the next slide shows here. We're putting it up. For a total of 6 inches of this stuff, so R30, all the way around the outside of the house with no thermal breaks of any kind. Well, almost no thermal breaks. It was a bit of a puzzle to figure out how to put it up, though, because it's quite a sandwich we were putting up. So 2 layers of insulation, and then you see the house wrap, and then the strapping over top, and then 8-inch screws all the way through the sandwich into the studs inside. Eventually we settled on, you can actually see the washers just poking out there. So we used 4-inch screws to hold the first layer on temporarily. Then we'd stick the second layer on, sacrifice some of our expensive 8-inch screws to hold that in place, then house wrap over top, then the strapping. And here we see our beautiful 8-inch screws that we used all around the house to hold all that together. Also, you get a little view here of our window bucks that maybe this is standard to you, but this is all things we had to learn. If you have 6 inches of exterior insulation, you have to somehow extend your window openings. And we were particularly interested in placing our windows to the exterior because my wife loves plants, so we wanted lots of windowsill area. So window bucks made of 3/4-inch plywood seem to have done really well so far. We're about 3 years in now. At the bottom, so our ICF foundation walls have, I think, about 2.5 inches or so of insulation on the outside, which leaves some more of our insulation sticking out over top of that. So we had to protect the bottom of that somehow, and we did that with aluminum flashing. You'll see it sitting here on a temporary plywood ledge that was just there during construction. And you can also see a little piece of the right angle critter guard, so that got attached to the front of the strapping and holds up the front of the flashing. So the whole thing is hopefully critter-proof. I missed a piece in the garage and discovered that mice love to burrow in this stuff, so important to tie it all together. On the right-hand side there, you see there is a little extra lumber underneath the not window bucks, the bucks for the door openings. We got these triple glazed wonders from Europe. They are super heavy, so we felt we needed good support for these things. So a little extra lumber and extra 8-inch screws to hold it all up. Again, seems to be holding out well. Flashing for all our door and window openings, I heard somewhere you should flash the opening, not the window. That's what we did. I hope it's right. We got this, what I thought was sort of self-adhesive rubber stuff. Turned out it's not really. It sort of sticks and then it doesn't. We had to go back for a can of expensive goo of some kind that made it stick properly. Heidi, again, is the person who installed almost all of this stuff, and we don't seem to have had any leaks so far. I guess it's working. Our siding didn't arrive until the beginning of November. Again, this was 2020, so we were happy to get it at all, but we had not planned to be doing siding installation in November. We were blessed with, I think, the warmest November we've maybe ever had in 2020. There was a lot of sunshine, very little rain, and very little cold, and so we were able to get it done. That's actually sort of the first and last day of siding work we did. You'll notice a lot of creative scaffolding and whatnot. This may not be quite how you guys would do this, but it worked for us. Yeah, you'll see there's a trailer axle on the bottom of that scaffolding. It worked. It worked for us very well. So here's a couple of shots of the attic space. We had raised heel trusses to give us lots of room for cellulose. That's what you see on the right, 30 inches of it for nominal R100. I don't know if it's really R100, but 80 or 100 makes no substantial difference anymore. Cellulose insulation, it turned out, is just about free, so you might as well put in more. I had no idea. On the left-hand side is the intake and exhaust for our ventilation system. 8-inch insulated ducts, and so our HVAC unit is about in the middle of our second floor, hence the ducts to the exterior. There's the inside view of our second floor ceiling, and you know all these bits of scrap lumber nailed to the underside of where the trusses are. And the reason for those is that we needed to create a 3-inch gap, so there's strapping installed over top of those, leaving 3 inches, which is just enough room for these funky little ducts. So this is European 75 millimeter plastic flex ductwork. Really do-it-yourself friendly. This stuff is dead easy to work with. I had to do a little bit of what you call tin whacking, I think, and that is supremely difficult. I was very happy to work with the plastic stuff. So that just fits in a 3-inch cavity, which also came in handy for running wiring and whatnot. Our blower door test. So Rob Blakeney actually has his own blower door, somewhat old one, but he brought it along and actually let us keep it for a while. And we came in about 0.8 ACH, which is not quite passive house standard as I understand it, but good enough for me. I was very pleased that 3M tape seems to have done the job. Whether it'll still be sticking 20 years from now is another question, but yeah, well, we'll see. We did some fussing around with details trying to improve on the 0.8, but we never could. I actually suspect it's the OSB itself that leaks to some degree. I have read stories about OSB leaking, and I don't know. Maybe we should have gone for plywood, but here we are. To finish the wall installation, the point of the picture is actually in the back, not what Heidi's doing there. So we put fiberglass bats in the 2x4 stud cavities. You know, it's actually 24-inch spacing framing on this house. That's how it was designed to cut down on lumber use a little bit. I wouldn't do that again because it means everything is only supported on 24-inch centers. So the drywall inside is a little more wobbly than you're used to. And more importantly, actually, the siding attachment on the outside is on 24-inch centers. And when it's windy, I can hear that stuff rattling around. I really would have liked 16-inch centers, I think. However, none of it's come off so far. We're okay. The total R value for our wall structure is R40, which is just fantastic compared to the old houses we've been used to living in. What Heidi's doing here, actually, she's putting some fiberglass in the first floor ceiling. We had hoped that that would provide us some acoustic isolation from between the second and first floor. I think it was a total waste. It doesn't seem to do anything. So you saw we have solar panels on the roof installed by Sand Solar out of Toronto. Actually, we had got a connection to them. They did a nice job of putting it up. It has not caused a single problem since we turned it on a good year and a half ago. So it's a 10 kilowatt system. Our house faces due south, couldn't be better. There is no shade, almost no shading. Neighbors 2 houses over have some tall pines that bother me in the early morning. Heidi says I'm not allowed to go cut the tops off, so I guess we have to live with it. The whole system cost us about $24,000. Mr. Trudeau kicked in $5,000, so our net cost is about $19,000. It's so far saving us about $1,000 a year. We're on net metering with our local Innova Hydro now. So simple payback is 19 years. It will actually be a lot shorter. We're hoping to get an electric car if you can ever buy one of those again. And that will use up some of our excess electricity. And, well, electricity prices only go up. And our net bill does not. Our net bill just stays zero. It's really nice. The insulation and air sealing, I'm sorry this slide got a little scattered, but I was sort of estimating, you know, I was interested in how much extra did we spend to make this house well insulated instead of standard construction, and make it well airtight instead of what the usual construction practices are. And overall, the extra cost is really not that big. This is sort of our total insulation and airtightness costs. About $13,000, and of course you'd spend some of that with usual construction practices. Now what I'm cheating on, of course, is I have no labor costs because we did it ourselves. So that's an unfair comparison, and you guys can guess better than me what would be a better comparison. The windows and doors did not come from here, I'm afraid. They are some European import. Assembled in Poland, I'm told, with German hardware and French glass. But they've worked perfectly so far. They're lowly vinyl, but they work really well, tilt and turn windows. And they cost us about $15,000, which seemed like quite a deal compared to other quotes I got at the time. That's 14 windows and 2 doors. So how does it work? is the key question. So I am an engineer, not a building engineer, but I am an engineer. And so this is the kind of thing that I want to know. And so I've been tallying energy use and generation and whatnot. So we're using just under 700 kilowatt hours a month to heat, cool appliances, lighting, and hot water heating. Just straight old electric resistance hot water heater so far. I haven't got around to upgrading that. The average Ontario household actually uses significantly more than that, doing just the usual electric things minus the heating and hot water heating. So taken overall, I think our house uses about a quarter of the typical Ontario home in energy, which is very gratifying to me. And our solar panels on the roof produce substantially more already implied, I think, than what we're actually using. So we have a real net zero house. And in terms of money, we have around zero on our hydro bill every month because we produce enough extra to also cover the fixed cost. The surprisingly variable fixed costs, actually, if somebody can explain to me what the Innova fees are, I can't understand them, but we're covering them. So the extra, I figure we probably spend $10,000 or $15,000 extra to make our house really well insulated and airtight. Typical heating costs, I researched, comes out to about $1,500 a year. So our simple payback on that is 7 to 10 years. Seems very short. This is our entire heating and cooling and ventilation unit. Minutair is a Quebec company, so it's Canadian made. It's kind of cool, a little pricey, and I'm not sure I would do it again, actually. It's a little underpowered. It keeps up down to around -3 or 4, and after that it needs backup heat, which is just electric resistance inline heater. So simple enough, it works, but I would like better. So we may add a mini split heat pump, something along those lines one of these days. So that's our house. That's what I've got to say about it. It took us about 15 months from when we broke ground to when we were able to move in. That is not to say that it was done at that point. We've sort of recently finished the last details, and my wife thinks we still need a driveway. But I'm very, very happy we did this. The energy performance is wonderful. It's what I've dreamt of all my life. And I have to say, I'm really happy to see a room full of professionals here, all keen on building things like this. I don't see a lot of that. When I look around at house construction, it's very sad. It seems to me it's been so easy to make a house that's well insulated and airtight. I think they should all be built like that, and I'm glad you guys are here making that happen. Thank you.